This is integrating Azure Stack into your data center. My name is Thomas Rodenscheer. I'm a program manager in the Azure Stack team. So welcome for making it over. I know a lot of you just may have grabbed lunch and just hopped over, so thanks for making the time. So over the course of the next 75 minutes, we actually will help a company that we used during the week called Contoso Construction to help them integrating their Azure Stack system into their data center. This is just a quick overview to set the stage so that you get the context. So Contoso Construction is a company that acquired Azure Stack for an application modernization project. They're deploying Azure Stack physically connected, but using Active Directory identities for authentication on Azure Stack. They will also use their existing System Center deployment to retrieve alerts and use those alerts to forward to their connected ticketing system. This is really to set the stage, because we're going to work in this scenario throughout the entire session. To make it clear up front what I'm not going to talk about, and those are really the solution specifics. So when you think about what are the rack dimensions of solutions, do I require re-racking? Do we support re-racking? All those type of questions I really defer to our hardware partners, and they're all over in the expo. So the expo today is still open till 4 o'clock, so I really encourage you to go over, talk to our partners, and have those conversations about power requirements, cooling requirements, and all those kind of solution specific when it comes to placing the system physically in the data center. Now, data center integration really starts at deployment time. It really goes hand in hand with deployment. To give you an overview of the deployment process on a high-level base, you see this is a two-way process between the customer, you, and our hardware partners. How many of you have been in a session from VJ on Tuesday? Couple? Okay. So the customer fills out what we call a deployment worksheet. And I'm going to walk you through that deployment worksheet here in a couple of minutes. Once that deployment worksheet is filled out, our hardware partners do take that worksheet, take the input parameters, and generate network configurations and deployment configuration files. The partner then deploys the solution, and you as a customer does the integration into your existing data center. Of course, that integration can also be done by a contractor that you contract to do the work. Now let's take a look how this worksheet looks like. So we're using Axle as a front end here, but again, it's just a front end. Behind Axle, there's an entire, what we call a deployment toolkit that auto-generates configuration files. Let's take a look at some of the inputs that relate to data center integration. So the first choice that you make is, how will I deploy? Will I deploy with Azure Active Directory, or will I deploy with Active Directory Federation services? There's some more information, like the region name, but here's where we start with information that really relates later in the data center integration section. You have to specify the external domain name. Think about it, what is the URL that you want your Azure Stack to be reachable under? Of course, we're also asking for private domain information. This is really for Azure Stack internal, that's the directory service. We ask you for certificates, and here we're going to drill deeper into certificates. In the worksheet, we're literally just asking for the password of the certificates. Then there's going to be some naming prefixes. We ask you for time zone. We're asking you for DNS forwarders. We're asking you for time synchronization servers. Now let me flip over to our networking settings. This is really where the majority of the work you will spend in planning of integration of Azure Stack. So for Azure Stack itself, we're asking for multiple different IP spaces, and only some of them are routable outside of Azure Stack. So you see we're going to ask, the most important ones I'm quickly showing you is, of course, the external network. This is where all your public IPs are taken out for VIPs and load balancers. You specify the BGP configuration. We have a switch infrastructure network. Again, those are supernets. What the tool really does in the background is it does a lot of subnetting. What I've shown you here really is what we call the generic customer worksheet, because the customer worksheet that you will see from your hardware partner will have more tabs at the bottom. Whereas they may ask you for device authentication, maybe you want to do TagX integration for the physical switches that come with Azure Stack. So bottom line is, each partner has their own custom sheet that is going to be extended from what I've shown you here. Now, seen in the worksheet, we only ask you for the certificate of the passwords. But now, diving deeper into the certificates. There are multiple endpoints of Azure Stack that do require a certificate. And you have the choice to either provide a single wildcard certificate, or you provide individual certificates to match the seed names. It's a total of 11 required certificates. Of course, certificates do expire, so we support the rotation of certificates to a functionality that we call the privileged endpoint that we're going to hear soon more about. So a summary. So there is a lot of information in the deployment worksheet that already feeds into Datacenter integration. External domain names, certificates, time synchronization, IP pools routable beyond the top of rack switch, syslog servers, device authentication. So there's a lot of information that already starts with the deployment. Great. So as an Azure Stack operator that integrates Azure Stack into a data center, it is important to understand what is the privileged endpoint and how do I use the privileged endpoint. Just raise hands. How many of you have been in the session yesterday with Filippo and Jeffrey Snover for security? Kabul? Okay. So in general, you can interact with Azure Stack in 3 different ways. Through the portal, through PowerShell, targeting the ARM, or through the privileged endpoint. So let me give you some insight into what is that privileged endpoint. Azure Stack itself is what we call a lockdown system. So the tools that you are used to use in your daily job, like Hyper-V Manager, Failover Cluster Manager, or any other MMC, you can't use in Azure Stack. So the only way to really drill deep into the system for diagnostic or troubleshooting, but also data center integration, requires you to go through that PowerShell-based and secured just enough administration endpoint. So with the help of GIA, we lock down that endpoint to only a certain set of commandlets. Of course, when you are troubleshooting the system, you can unlock that privileged endpoint to have all commandlets available. This unlocking process is a 2-way process. So there's one token that we have, and you get a token back from Microsoft support to really unlock that PowerShell session. The takeaway I want you from here is, for data center integration, you do not need to call support. So we can run all the commandlets required for integrating Azure Stack into a data center in locked mode. So you don't need to call support. Now let me show you how that looks. So remember, we're talking in the context of Contoso construction. Contoso construction just received their Azure Stack system. Now you're sitting there and go like, well, how do I know how to connect to that privileged endpoint? What is the IP address of that privileged endpoint? So once the hardware partner has finished the deployment, they will hand you over an information file that contains all the details of the solution. That file is called Azure Stack Stamp Information. And this particular file contains all the information required to integrate Azure Stack into a data center. For example, here you see the IP address of the privileged endpoint. So that's the first information that we're going to require to interact with that privileged endpoint. You can connect from that privileged endpoint from any of your workstations, technically from any machine that has network connectivity to that privileged endpoint, to that IP address I've shown you. In order to do so, you need to configure the WinRM to have that privileged endpoint IP as a trusted host configured. So I've done that in advance. So what I'm going to essentially do is I require, obviously, credentials to connect to that privileged endpoint. And by default, there is one user that does exist in the system, and that user is called Cloud Admin. So what I'm doing here is I'm entering a remote PowerShell session to that privileged endpoint and specifying the configuration name and pass the credentials. Yeah. Let me try that again here. Keep in mind, those are all live demos. There might things that may go wrong, but this looks better. Great. So we've established a session. Let me just do a clear screen here quickly. So the first thing I want to show you is we're running in locked mode now, meaning I only have a small subset of commandlets available. So let me show you those commandlets. Right? So this is just a small subset of commandlets that you can run in that locked mode. Let's quickly count them up. Okay, don't worry about that part. Now, I've shown you that getStamp information file. This file can be regenerated at any given point in time, and this is just one of the commandlets that is exposed as part of that limited set of commandlets. So we can just run that commandlet, and don't worry, we're going to run a lot of the commandlets in that privileged endpoint related to data center integration. Okay. So you see that's the same content that I've shown you earlier in that notepad file that you get handed over by your hardware partner. So again, you can regenerate that file at any given point in time. All right. This is, again, a summary of that privileged endpoint. So we used a user called Cloud Admin that exists by default. It has the same password that you specified for deployment. The password can be changed through the privileged endpoint, and you can create additional equivalents of that Cloud Admin user through that privileged endpoint. I've shown you where you get the IP address to connect to that privileged endpoint. And I've also shown you how you can regenerate that stamp information. And again, the biggest takeaway is for data center integration, you don't need to unlock that PowerShell endpoint. You don't need to call support. Now going deeper into data center integration, this is really an all-up view of typical data center integration touch points. So we talked about the IP space that you have seen in the customer worksheet. Based on experience, this is where you may spend a lot of time in the planning phase. We need to configure the uplink from those top-of-rack switches that come with the solution to your network switches. We've seen the syslog server being captured, we've seen the time server being captured, and we've seen device authentication being part of the customer worksheet in sections from the hardware partners. So that top row, I really want you to think of like information that feeds into the deployment process already. The bottom row, I want you to think about those are all steps to integrate with DNS, to integrate my identity system, to configure my firewall, securing the endpoints, and doing integration with my ITSM system. Those are all post-deployment steps. Now looking deeper into the uplink from our top-of-rack switches to your switches. Based on our experience, there is a big mind shift when we talk to networking engineers. This uplink is not a layer 2 based uplink, it is a layer 3 uplink. So the network design that we use for Azure Stack is based on a class topology. So this is a pure layer 3 uplink, meaning we are assigning IP addresses to the ports for the point-to-point links that go from your switches down to our top-of-rack switches. The routing protocols that we use in order to announce IP space from Azure Stack up into your network and the other way around, preferable would be BGP. Why? Because every time you're exhausting your public IP address pool, you can add address pools at any given point in time. And with the help of BGP, those address pools are automatically announced to neighbors, and you don't need to touch any of the static configuration files. But of course, we do understand BGP is not used all over the place, so we also support static routing. So from the Azure Stack solution itself, the implementation is fairly simple because we just do a single static route entry and send just all traffic up to your devices. On your side, on your routing tables, this is really where the work starts because you have to define all the networks that you want to send down level to the point-to-point links in order to reach our top-of-rack switches. And again, once you expand on IP pools, you have to touch those entry all the time. So it's no longer a seamless process. Again, what I want to call out here is if you want to have more detailed discussions about what are the physical modules that I require? Is it SFP Plus, right? Go and have those conversations with our partners, right? Now, again, setting you back into the mind stage of Contoso Construction. Contoso Construction wants to use Active Directory to log on, to authenticate to the Azure Stack system. And for that purpose, we deployed Azure Stack with ADFS. So what you see here in the gray box is really a layout of Azure Stack components when deployed with ADFS. So we have our own instance of ADFS running part of the infrastructure roles. We're also having a component called AD-Graph. Don't worry, I'm going to dive more into what that AD-Graph component does. And of course, we do have our directory service running in Azure Stack. Portal, Azure Resource Managers, Resource Providers applications, they're all using the built-in ADFS instance. And this is really what you also get with our OneNote system. Now, obviously, once we want to integrate that into a production system, we want to integrate with your Active Directory and your existing ADFS deployment. So we're building a ADFS Federation Trust. So your ADFS becomes the account STS, while our ADFS is the resource STS. And we have to configure the AD Graph service to be able to look up accounts in your Active Directory to make this work happen. And this is really how we're going to integrate that. That's just on a high level, but we're going to dive deeper into each of the sections. Now, of course, in order to do that ADFS integration, we first need to make sure that DNS resolution works between Azure Stack and your environment. So Azure Stack itself does come with two different DNS zones. An internal DNS zone that is really tied to the internal infrastructure roles of Azure Stack, and it comes with a DNS zone for that external domain that you specified at deployment time. Now, in order for us, for Azure Stack, to resolve your ADFS endpoint, we're using conditional forwarding. The other way around, from your environment to resolve the external Azure Stack domain, there are multiple options. Of course, you can use conditional forwarding, you can use route hints, you can use stop zones. That is your choice. Now, going the next step when we talk DNS integration, when we get to the point to publish Azure Stack to the internet, we need to think about how do I make sure that I can resolve my Azure Stack endpoints from the internet. So there are the most common scenarios here really is you have the domain registered at a provider, and you modify the registrar's entry to point to the name servers of Azure Stack, or you configure conditional forwarding on that external DNS server provided by the registrar of that DNS domain name. Now, I promised you we're going to look more into Graph. So the AD Graph service is a service that on a high-level base enables all the RBAC scenarios in Azure Stack, no matter if it's on the operator side or if on the user side. Now, the Graph service does require a user account from your Active Directory with read permissions. We do use the LDAP protocol to make that call to your domain in order to query the user objects. Once we've gathered the user objects, we pass them to our policy server. And our policy server does a match to enable those RBAC scenarios to pass them back to Graph, to ARM. I've put this slide in as a feature summary when deploying with ADFS because we've seen several discussions in the past. So again, Azure Stack allows you to deploy in physically connected scenarios, but also in disconnected scenarios. What does it mean for identity? When I'm physically disconnected from the internet, when I'm on a ship, the only way for me to deploy from an identity perspective is ADFS. But as long as I'm physically connected and I do have internet connectivity, I can deploy with Azure Active Directory or ADFS. How does this impact my billing? So when I'm physically disconnected, I can't send pay-as-you-go data up into my Azure. So my only option is the capacity-based model. When I'm physically connected, I can use capacity or the consumption model. Marketplace syndication. When I'm disconnected from the internet, I can't syndicate images from the Azure Marketplace down into my system. Not today, but we're working on to enabling a sideload option of those Azure Marketplace items. Registration of the system, very similar. When I'm connected, I can run the script to register Azure Stack. When I'm disconnected, we require a removable media to transfer the registration information. Patch and update. How many of you have been attending Justin's breakout session on patch and update? Couple, okay, great. So Justin, you can bring in an update by uploading an update package into a blob. So for PNU, it doesn't matter if you're physically connected or disconnected. It's always the same process. You take the update package and upload it to the blob storage. Now, what is supported when deploying with ADFS? We do require Microsoft Active Directory. Currently, we do not support integrating with any other LDAP-based directory other than Microsoft Active Directory. The supported ADFS versions, so we require at a minimum Windows Server 2012 ADFS, 2012 R2, or 2016. Great. So with that, we're switching back into a demo. So remember, Contoso Construction just received their Azure Stack system. So I'm on my workstation here for Contoso Construction. When I'm trying to load any of the portals, no matter if it's the admin portal or the user portal, doesn't work, right? So I don't have any DNS integration to start with. You've seen earlier, I already do have network connectivity. Because I can reach the privileged endpoint. So the first step is obviously configuring DNS integration. So I'm going to start off on the Contoso Construction side. Again, it's your choice if you're going to use conditional forwarding, if you use root hints, if you use stub zones. Again, this is your own DNS server, you own it. It's your choice how you do that configuration. So in my case, I decide to do conditional forwarding. So all I'm quickly doing is I'm setting up a conditional forwarding. Again, if you're wondering the external domain zone of Azure Stack, keep in mind you always have the Azure Stack stamp information file at the bottom. You also have the external FQDN domain information. Now, what IP should I point to for the Azure Stack name server? Again, it is in our stamp information file. So you see here the external names, you see them as names, but you also see the IP addresses. So I'm just copying my IP address out of the information file. Yeah, thank you. Great. Now let's see if we get a step further here. Look at that. We can finally at least have a DNS resolution working from Contoso Construction to Azure Stack, and I can start browsing the portal. First thing that you're going to notice is I'm getting the login page for ADFS come in from the Azure Stack ADFS. That obviously doesn't know any of my identities. My identities live in my Contoso Active Directory, so my next step is obviously setting up that federation between the on-stamp ADFS and the ADFS of Contoso. As I promised you earlier, we're going to use the privileged endpoint for all those operations. Since we're already connected, I'm not running that section again. So there's 4 major things that we have to do. The first part is we're configuring Azure Stack to resolve the Contoso domain name in order to reach the ADFS endpoint. All we really require for that is what is the domain name? In that case, it's contoso.com, and we require the IP addresses of Contoso's DNS servers. That's all the input that we do require. What you see here in the background is kicking off automation in Azure Stack to do the configuration for us. That just takes a couple of seconds. While this is running, the next step that we're doing is we're configuring the AD Graph service to be able to look up users in your Active Directory. As I told you earlier, for that purpose, we do require a user account in contoso.com in order to do that lookup. So what I've already done in advance is I did create a user account that I called Graph Service. Again, you don't need to create that user account. You can use any other existing service account that you already have. For this particular commandlet, all we do require as an input is the global catalog. In that case, that's contoso.com. So again, that will run a couple of seconds here, that automation script. And now it's going to be prompting me for the username in order to access the Active Directory of contoso.com. So let me give him the account. So while this script is running, our next part will be to set up the federation trust. Now, as a lot of you may be familiar with, this is a two-way process, right? It's not just in one way, it's in both ways. So again, we provide the automation to do the setup in Azure Stack, but we're not providing you, let me put it that way, we're providing you the steps to set up the claims provider trust on your end. So we're providing the claim rules in documentation, but in order to minimize errors, we have put on our Azure Stack Tools repo on GitHub, we provided a script, and that's exactly what I'm going to do next, is I'm going to show you that particular script that really does the entire ADFS configuration for you. What that script really does is all it requires is the input of the external Azure Stack DNS zone. That script has logic built in, so it also understands if you're running a 2012, a 2012 R2, or Windows Server 2016 ADFS, because the commandlets are a little bit different between the versions. So it makes sure that it's reflecting the version that you have. Now let me flip back and see if the graph configuration finished. So that finished. Now, before I run the ADFS configuration on Azure Stack, what I want to point out is the input parameters do require the federation metadata endpoint. Now, there may be scenarios where we can't reach that endpoint. Might be through different certificate trust chains, might be through security, that there is no connectivity between the ADFS instances because only clients can reach both ADFS instances, like Microsoft IT, for example, just calling out one example here. So for that purpose, we also allow to just provide the metadata configuration file. So in that case, you would do an invoke web request on a machine of your existing network to pull down the metadata and create that file and just pass us on that file. You may have grabbed that in the background here quickly. So we're reaching out to this metadata endpoint. We're doing an invoke web request. We're pulling down the content. We're storing it in a file ourselves in order to use it. But again, if there is connectivity not available on purpose, you can just provide us the file as well. So this may run a couple of seconds here. While this is running, I go back to the Contoso's domain controller. So in case of the Contoso, we have a domain, Active Directory, and ADFS combined on a single machine. So that's why I'm running this particular script to set up ADFS also on the domain controller here, just to give you context. So you see the script does network validation, make sure it can reach the endpoints. It does check the metadata that it can retrieve the content, and that's it. So let me show you what the script has done. So let me bring up another MMC here quickly. My bad. Give me a second. I'm just connecting over to our domain controller. I don't want updates. Not today, but thank you. Let me bring up the ADFS management so it doesn't let me allow to do remote management. So all I want to really quickly show you is what the script really does. So the script does configure my relying party trust, configuring the identifier, it's configuring all the claim rules for me, so it does everything for me. Of course, again, you can do this all manually. We have the claim rules all documented in the documentation if you prefer to do copy and paste. Our experience have told us we've seen a lot of failures just by doing copy and paste, so that's why we provided the script on our GitHub repository for that purpose. Okay, let me minimize our domain controller here. The script has also finished. Now going back to our portal, and let's do a reload here. As you can see, we're now getting the login page from Contoso's ADFS instance. So if you have customized your ADFS login page, this is where you're going to start seeing it. So in this case, you just see it's now the ADFS login page from contoso.com. You can also recognize it on top in the URL that ADFS is now loaded from Contoso. Now, I want to quickly demonstrate you what's going to happen when I'm trying to log in now. So the Azure Stack portal does load, but you will see a lot of missing things. It doesn't have any knowledge about the owner of the default provider subscription. So what we have to do is we have to run one more script to configure who's the default owner of the default provider subscription. So in that case, I'm going to make the owner of the subscription administrator Contoso.com. Now once this is done, at that point, I can use just a traditional RBAC concept in the portal of ARM to delegate permission to operate Azure Stack to additional operators in my Active Directory. So this should be a pretty quick process here. Once we reload the portal, you will see that you have access to all the infrastructure resources in order to operate Azure Stack. Great. So let's go back and reload the portal. No, thank you. Give it a second. Let me just reopen the portal in order to update the credentials. Guess it's not the day of Internet Explorer. Guess something must have gone wrong, but we're going to take a look into that at a later point because we do require that. All right, let me get back to the presentation. Now that we have integrated Azure Stack from an identity and DNS perspective, the next part we're moving to is publishing Azure Stack either to the internet or to our corporate network. Let me start by giving you an overview. So there are various infrastructure endpoints that you have seen earlier when we talked about certificates. Those endpoints do use IPs from a shared public pool with the users. So it's a single pool of public IP addresses that is shared between infrastructure endpoints like the portal and resources that tenants do create. We have all the ports and protocols required to publish Azure Stack documented. That documentation went live on Monday. I'm going to show you the ports later on. Again, I talked about that IP pools can be added at any given point in time to expand the capacity. And even if I keep using the word public IP pool, you don't need to provide public routable IP space for that public IP pool. This can be also a non-routable public IP pool. Now let's take a look on how we secured Azure Stack even without touching the firewall. So you see the different layers, the customer firewall, the customer border devices, equally the switches to where we connect it, Azure Stack top-of-rack switches, you see our top-of-rack switches, and you see the software-defined networking stack. Generally speaking, we have three major VIP pools. One where we have all the infrastructure VIPs sitting. Again, those are portal ARM endpoints that we talked earlier. Then Azure Stack has a lot of internal VIPs for infrastructure roles. Those will not get announced beyond the top of rack switches. So we have access control lists in place to make sure that no traffic is coming in or going out in order to hit the internal VIPs of Azure Stack. And then we have, of course, the user space. This is really where the same experience as you have in Azure. Every time in Azure you create an NSG, you use a public IP, or you use a load balancer. This is where those IPs do live in that public pool, in that IP pool. So the infrastructure and the user pools are really the ones that are routed up to your customer firewall that you want to secure. Now, how does this look from a placement perspective? So generally we identified two major scenarios. The first one is what we call the edge deployment. So the edge deployment, you have Azure Stack either placed directly behind your ISP router, or you put a firewall in between. The reason I say, or you put a firewall in between, is really because Azure Stack itself does not require to have a firewall in front of it. But we still do recommend it in order to protect for DDoS attacks. This is really where the firewall brings in enhanced technologies to help you with DDoS protection. In this deployment scenario with the edge deployment, you can see, if you take your focus on the Azure Stack box, on the public VIPs, in this scenario we really use public routable IPs. Now, what is new with Azure Stack in terms of your firewalls? So Azure Stack brings storage services, blobs, queues, tables. And firewalls do have a certain amount of throughput. So I want you to carefully think about the throughput capabilities of your firewalls, because as soon as tenants start using those Azure storage services, they start pumping data into those storage services. So that means your firewall throughput will go up, so keep an eye on those. What's the second scenario? This is really the traditional scenario that we all know very well. And this is really the typical enterprise deployment scenario where you have a DM set, you have a two-layer firewall concept, and you have deployed Azure Stack beyond the second firewall. And what I've called out here is, in the most common deployments, your public VIP pool will consist of non-routable IPs. So in that case, the second firewall that you see here will do network address translation, it will do NAT. That's a typical enterprise deployment scenario. Of course, it could also be public routable IPs, but most common, this is where you would be in the NAT scenario, network address translation for enterprise deployments. Now let's take a look, and this is what you have all been interested for, is how do those ports requirements look like when I configure the firewall. So as I told you, the documentation went live on Monday. So you now see all those port requirements in our documentation. Okay, scary message. The endports you've seen earlier in my overview slides with certificates. So those are the same endpoints. Again, what we're showing here are the infrastructure endpoints and the port and protocol requirements for you to publish the Azure Stack services. So it's a huge list. We also have documented the outbound requirements. So it's not just inbound, but also outbound if you're controlling outbound. So you really see what are the URLs, the ports, the protocols required for identity when you're using Azure Active Directory. What are the requirements in order to enable marketplace syndication? What is required by patch and update in order to fetch the updates? What is required by the registration service, but also the usage service? Let me fill it back because this should raise a couple of questions on your mind. How do I manage firewall rules for my tenants? Great, Microsoft, that you gave us all the ports and rules for the infrastructure endpoints to reach the portal to reach ARM, but what's the best practice to control access to my user endpoints? So users in Azure do manage their own networking firewall rules. So when you're in Azure or in Azure Stack and you configure a load balancer, you configure a network security group, you manage your own rules. So you don't need to call Microsoft support to tell them, hey, I've just configured a service on port 80, please open up that port. So that's not really that true self-service experience. So again, how does this map into our firewall configurations in Azure Stack? Of course, you can have all the remaining pools or IPs in that pool that are not consumed by infrastructure configured just to be in any rule, and maybe just add content inspection on top to really achieve that true self-service experience without users calling the IT department and ask them, hey, please add an additional firewall rule. Of course, there's another approach that is more IT controlled, where you go with a well-known subset of ports, like port 80, port 22 for SSH. So you go with a well-known subset and just reduce the amount of calls to the IT department, but still give some control to the IT department. So go with a well-known subset. And of course, you can go with the full control model for the IT, where, as I said earlier, you just don't open any of those ports. So after users create their own firewall rules in their networking security groups or in the load balancer, they will call you for every rule that they create. They will call your department and ask to open up those ports. That's really full control to the IT department. Those are the three approaches that you can take with firewalling rules for the tenant space. Now let's shift gears here a little bit and talk about ITSM integration. Let's start by giving you an overview. So all the orange boxes is really what you get with the Azure Stack system. And I want you to think of Azure Stack, of the integrated system, in three buckets. The first bucket is really the Azure Stack software. The second one are the physical servers. And the third bucket are the network devices. Those three buckets make up the Azure Stack system, plus the hardware lifecycle host that comes from the hardware partner. So the hardware partners have put monitoring software on the hardware lifecycle host, specifically targeting for the physical servers and the network devices. For the Azure Stack software, in order to retrieve all alerts from Azure Stack, we provide a REST-based API. In order to interact with the physical servers, we're going to connect directly to the baseboard management controllers using the IPMI protocol. For networking switches, we're using the SNMP protocol. Now, obviously, there is an option that you can just bypass the monitoring software on the hardware lifecycle host, because you want to have all the alerts of the entire Azure Stack solution, no matter if it is software alert or a hardware alert. You want to have this all consolidated in your existing monitoring system. The key point here is it has to be all agentless. You can't place any monitoring agents on Azure Stack. That's why this is direct communication with the baseboard management controllers, communication with the network switches through SNMP, or interacting with the REST-based API of Azure Stack to retrieve events. Now let me show you what are the available solutions. So in order to integrate the Azure Stack software with the REST-based API, last year I've already shown you a Nagios plugin that we've created to retrieve events from Azure Stack. We now also have a Systems Manager, Operations Manager pack, or you integrate directly with the REST API or PowerShell. For the physical servers, again, if you are a System Center customer, you can import the management packs from the hardware partners that are operating agentless in order to retrieve hardware events. Again, there are hardware vendor plugins out for Nagios or any other OEM-based vendor monitoring solution. Again, key, it has to be AWS. Very similar to the network devices. And last, I want to quickly focus on the tenant subscriptions here. So how do you monitor your user resources? And for that purpose, you can either use the Azure management pack that exists for SCOM, but you can also use OMS or any other monitoring solution that you want to deploy in the user space. Again, that is the user space. Now, for today's session for Contoso Construction, they want to integrate with their system center deployment. And what I'm showing you here is really, you see Azure Stack, you see Operations Manager, and you see Service Manager. So the management pack for Azure Stack does allow you a bidirectional communication. So once alerts flow over from Azure Stack into Operations Manager, I can also close alerts in Operations Manager, and the alerts get closed in the Azure Stack system. But this is not where we want to stop. We want to have service incidents automatically created out of alerts that are generated in Operations Manager. And for that purpose, we can interconnect Operations Manager with Service Manager just out of the box. There is no additional software required, it just works out of the box. And here, it's your choice if you want to have that connection to be bidirectional or if you just want to have it one way. Meaning, if you close a service request, do you also want the alert to be closed in Ops Manager and in Azure Stack? Again, that's an implementation choice that you can make. If you want to go even further, you could also bring in Orchestrator or SMA to have other service requests from Service Manager be triggering actions in Azure Stack by calling into Orchestrator or SMA, executing PowerShell against Azure Stack. So this is really the enhanced scenario here. Contoso Construction is focusing on the green box. That's what you really get out of the box without any customization. Simply importing the management pack that we provide for Operations Manager and interconnecting it with Service Manager. Let me flip back to my environment. That hopefully reconnected the VPN. That's looking good. Let's do a quick refresh on this portal. Okay, that still doesn't like me. All right, let me flip to a backup environment here quickly. I don't want updates. Now what you see here is the Operations Manager dashboard for Azure Stack. And we actually do have multiple dashboards. So we do have a dashboard that is dedicated to alert management, but we also do have a dashboard that is dedicated to capacity management. But before we dive into the dashboards, let me quickly show you the configuration of the management pack, which essentially gives you the same experience as the Azure management pack. Okay. Yes, no, maybe. There it goes. So as you can see, I've already configured one Azure Stack environment. The management pack does allow you to configure multiple Azure Stack deployments. So you can not only monitor your production deployment, you can also monitor pre-production deployments, or if you're a service provider, you can monitor multiple Azure Stack deployments for your customers. One focus I want to show you is when you configure the deployment. Now, for that purpose, I'm just putting in quickly the endpoint URL. Okay, he's intelligent. He knows I've already edited that. This is what I wanted to show you. How do you authenticate to the endpoint in order to talk to the health resource provider to retrieve all those events from Azure Stack? So why is this important? So when you deploy with Azure Active Directory, you can authenticate using a user principal. But for ADFS, you need to create a service principal. That service principal requires certificates. And those service principals are created through the privileged endpoint. Why? Because tokens do expire. You want to have a permanent monitoring solution, and you don't want that token to be expired. That's why you're going to use a SPN when you deploy and monitor a ADFS deployment. All right, let me flip back to the presentation. Now, hardware does fail in data centers. So we integrated Azure Stack into Contoso's data center, and now we're keep operating Azure Stack in Contoso's data center, and hardware does fail. So we've designed an experience in Azure Stack to provide that field replacement of parts, short through, which really addresses a couple of scenarios. A full node replacement, hardware component failures, and here we divide into hot swappable components and non-hot swappable components. You will have disk failures and network switch failures. So those are the four major scenarios that we address as part of field replacement of parts. Now, touching on roles and responsibility of the through process. So the hardware partner's responsibility is the hardware replacement. The Azure Stack operator responsibility is executing the node action provided through Azure Stack, either UX or PowerShell. So how do those processes look like? Let me give you an overview. So the first one is a full node replacement. So the scenario starts with an alert. So you get an alert in the system that a node might be down or experiencing issues, and you know it has to be replaced. So you start by draining the node, making sure that all active workloads are moved away. You power off the node if it's not already totally broken. That's why you see that box being yellow. And then you have your hardware partner coming in, replacing the entire node. And then it's the Azure Stack operator's responsibility to execute the repair action. Once the repair action is executed, we're going to validate the storage health by using the privileged endpoint. And then we just make sure and check that the alert got resolved. Again, this is on high level, but I'm going to show you the process as well. What I also want to call out, the processes that I'm showing you here are the generic processes. The details of the processes are covered by our hardware partners. Hardware component failures. Again, it starts by an alert. You drain the node. You power off the node. The hardware partner comes in, replaces the broken component. And here is an important step. Depending on how long that particular hardware component was on stock, you have to validate that it has the right firmware level to bring it back into the system. Once that is made sure that the component has the right firmware level, again, you execute the repair action, check the status of the storage through the privileged endpoint. Last step, you check that the alert was resolved. Now let's pick on this firmware update process. So this firmware update process, again, you drain a node, and then you see it's going to be a continuous circle to apply firmware updates on components till you hit all the components that do require a firmware update. This firmware update is initiated from the hardware lifecycle host. So our hardware partners do provide the tooling on the hardware lifecycle host to update the components Once you've updated all the components, you have to check the health status of the virtual disks before you move on with the next node. Obviously, you then resume the node in the UX or through PowerShell to make sure that it's available for placement again. The next scenario does focus on data disk replacements, which may most likely be the component that you most replace. Again, it starts by an alert that you have a faulty disk. The OEM comes in, does replace the disk, or he just ships you a disk. Again, this depends on the support contract that you have with the hardware partner. They may just ship you a disk and you do the replacement yourself, or you have a full service. Important here, Azure Stack does validate if the drive that you put into the system is a supported model, and if it is, it also checks if the firmware on the drive is a supported version. If it is not, we quarantine the disk and give you another alert. Once you have the right disk, we automatically start the repair process of the storage system, and then all you do is check that the alert has been resolved. Now let me show you a demo of the scale unit node repair. So for this purpose, I've recorded a video. So what you're going to see, doesn't want to play? There it goes. This might be potentially the fastest node replacement you've ever seen, because it's taking us 2.5 minutes. So you see, we have an active system, 4 nodes, all in a running state. My first action is draining that particular node. If you look at the details, you also see this is a Dell system. You see the BMC IP information. Now I've executed the drain functionality, and you see the operational state here switches to maintenance. As a next step, I'm executing the repair functionality, and all as it requires me to input is the BMC IP address. Why? Because that may have changed. Now at that point, it becomes a pretty boring process. That's why I've mainly recorded the video, because now everything happens in the background. So as you see, the server gets powered off. The UX will show you that the machine is in a stopped state. It actually removes the node from the active scale unit. It powers it back on. You're going to see here in a second, it does a pixie boot. You see, this is where you see the machine removed. It redeploys the operating system, adds it back to the cluster. Again, we're checking through the privileged endpoint if the storage is in a healthy state. And very soon, the UX does refresh, and we should see the machine coming back into a running state. So this was the fastest server node replacement you may have ever seen. Great. Now I've shown you a lot of things in this session. So we looked at the deployment worksheet. We looked at the privileged endpoint. We've integrated Azure Stack into Contoso's Datacenter. We've set up DNS integration. We've set up ADFS integration. We looked at ITSM integration. We looked at firewall, publishing, ports. And we looked at the field replacement process. There are essentially 2 things I haven't covered. One is integrating with your existing billing system. So I encourage you, there is a session from my colleague Alfredo, who talks about how you integrate Azure Stack from a billing perspective, with the billing systems. And I haven't shown you how we integrate from a backup perspective, because we do require for the infrastructure backup, we ask you for a SMB file share. So I haven't shown you how you set up and configure that file share and bring that into Azure Stack. Those are the 2 parts from a software perspective I haven't shown you. Now, how do you get started with Azure Stack if you haven't already? So you can start in Azure, apply policies to your Azure subscription so that they behave as Azure Stack. You can run our development kit to validate Azure Stack, and then obviously deploy Azure Stack multi-node systems for production. We're also running small sessions over in the Hyatt Regency, what we call immersion zone. So there are small groups, some short sessions, and you can then take hands-on on Azure Stack. But we're also giving out in the Expo area, we're giving out coupons so that you can get full access to an Azure Stack system and take hands-on there. And again, I want to also encourage you to stop by our hardware partners and have conversations with our hardware partners around data center integration. Do they support re-racking? Because that is a topic that comes up very often. Around power requirements, so have those conversations with our partners in the Expo, open till 4 o'clock today. So you already made it very far, so there's a couple of more sessions to go on Azure Stack. Again, you see the session here from Alfredo that is BRK3116. This is all about usage and billing. And then you have a theater session on recovering Azure Stack. So a couple of more sessions to go. With that, I'm asking you to evaluate, fill your evals. We appreciate the feedback. If you want to see more of those integration sessions, with that, if you have any questions, we have 2 minutes left. If there's any questions, feel free to use the mics for questions. Otherwise, I'm saying thank you very much for attending today. It's a pleasure to have you here. Thank you.